Before school, desks were randomly assigned a graded or practice test. There were 30 desks, so we assigned them 1 through 30. We used the random integer function on the calculator to find the random assignment of the desks. The first half of numbers chosen by the calculator will receive the graded test, and the remaining desks will be given the practice test. The random assignment will ensure that there is reduced bias. The same procedure was done for the other classes based on the size of the class. The test that we administered is a basic grammar test that both AP Literature and English 12 students have covered equally. Mr. Hayes has a first hour AP Lit class and a second hour English 12 class, so those are the classes we sampled from. In order to keep the subjects unaware, Mr. Hayes won't say who gets what treatment, if the test is graded or isn't graded. Mr. Hayes will say, "No more talking." He will then proceed to pass out the basic English tests face down that were stacked before school based on the random assignment. He will tell the class, "You have 5 minutes to complete this," and once the timer goes off after 5 minutes, he will say, "Pencils down," and he will collect the tests.
This is a table of the results of our 2 classes that were sampled. The students that had the graded test from first hour and second hour were combined, and the students that had the practice test from the first hour and second hour were combined. At the bottom of the table, it shows the averages and the standard deviations from the 2 samples. So the test that we've decided to do is a 2-sample t-test for difference between 2 means. Our null was there is no difference in test scores, knowing if a test is being graded or not, or mu y minus mu n equals 0. Our alternative is there is a difference in test scores, knowing if a test is being graded or not, or mu y minus mu n is greater than 0. Mu y equals the mean scores of the students that knew the tests were being graded. Mu n is the mean scores of the students that thought the test was practice. Our significance level for this test will be 0.05. Before we carry out the test, we need to check conditions. First, we need to see if it was random. The desks were randomly assigned, so that condition is met. Next, our normal condition was met since both samples were at least 30, so they passed the central limit theorem. Lastly, for independence, our 2 samples were both 30 and 33, so we need to assume that there are at least 630 seniors total, so that our sample sizes are less than 10% of the population. In addition, we need to assume that one senior does not affect another. This is the equation for performing a 2-sample t-test for difference between 2 means. It is t equals x bar 1 minus x bar 2 minus the difference between mu 1 and mu 2 divided by the square root of s1 squared over n1 plus s2 squared over n2. X bar 1 is the mean of the graded tests from the samples. X bar 2 is the mean of the practice tests from the samples. Mu 1 and mu 2 are the population means for graded and practice tests, respectively, which would equal 0 according to our null hypothesis. S1 and S2 are the standard deviations for the graded and practice tests, and N1 and N2 are the sample sizes from the graded and practice tests. Once we've plugged everything in, t equals 3.398.
Now that we have our test statistic of 3.398, we have to find the degrees of freedom before we can find the p-value. To find the degrees of freedom, we take the number of people in the sample minus 1. In this case, we will take the smaller degrees of freedom, which is 29. Now that we have our degrees of freedom, we look to the t-distribution table to find where our p-value would be. First, we must look at the df column and scroll down to 29. Once we find the row with the degrees of freedom of 29, we will move over to where our test statistic would be of 3.398. In this case, it lies between 3.396 and 3.659, which means the p-value is in between 0.0005 and 0.001. Our p-value is less than the significance level of 0.05, so we can reject the null hypothesis and conclude the alternative, as there is statistically significant evidence showing that there is a difference between test scores.
Pitfalls and shortcomings. We assume the size of the senior class was 630 or greater, but we don't know this for sure, so independence may have been violated. Although the students were told not to speak before they received the test, they could have looked or talked to one another. Also, since it's the end of the year, students are worn out and their motivation isn't up to par, meaning that they will not try their hardest on the tests.